Have you ever wondered why a metal spoon gets hot when you leave it in a pot of boiling water? Well, it's all because of a fascinating concept known as thermal conductivity. Thermal conductivity might sound like a mouthful, but it's a simple concept at its core. It's the measure of a material's ability to conduct heat. Imagine you're in a room with one end being heated. The rate at which that heat spreads to the other end of the room is essentially what thermal conductivity is all about. Now let's delve into the world of thermal conductivity in fluids. Fluids, whether they're gases or liquids, behave a bit differently from solids when it comes to conducting heat. In solids, heat transfer occurs through vibrations of atoms and molecules. But in fluids, it's a different ballgame. The heat transfer in fluids occurs primarily through the movement of the fluid itself, a process known as convection. Think about a pot of water on a stove. The water at the bottom of the pot gets heated first. As it heats up, it becomes less dense and rises to the top, allowing the cooler, denser water to sink down and get heated in turn. This cycle continues, creating a flow within the fluid, which effectively distributes the heat throughout the pot. That's thermal conductivity in action in fluids. But how do we measure thermal conductivity? For that, we use a unit called watts per meter Kelvin. The higher the number, the better the material conducts heat. For instance, metals like copper and silver have high thermal conductivity, while materials like wood or plastic have low thermal conductivity. So, to summarize, thermal conductivity is the measure of a material's ability to conduct heat. In fluids, this process primarily happens through convection, the movement of the fluid itself, and the unit of measurement for thermal conductivity is watts per meter Kelvin. Understanding thermal conductivity is not just for scientists or engineers. It's a fundamental concept that affects our everyday lives, from cooking our meals to heating our homes. So next time you're waiting for that pot of water to boil, take a moment to appreciate the science behind it. And that, my friends, is the magic of thermal conductivity.